This is the first part for lesson 12.4. Okay, to do a warm-up, I want you to first identify the mean and the standard deviation from this list of numbers. So remember, you can use your calculator to actually do both of them. And then identify the graphs as left, and then identify the graphs as skewed left, right, or if they're symmetric. Okay, for the mean for this list of numbers, it comes out to be 92.57, so I put 92.6. It didn't say where to round, so if you put 0.57, that's fine. Standard deviation at 7.925, so I put 7.93. Number 3, this one is skewed left, and that's because it tails off to the left. Number 4, it's probably more symmetric than anything because it does rise in the middle. You could possibly argue that it was skewed left, but I think it's more symmetric. Number 5 would be skewed right, and number 6 would also be symmetric. That's a lot easier to see. Okay, we're going to talk in this lesson about standard deviation. And so standard deviation, we've learned how to find standard deviation, so now we're going to talk about what it means and what we use it for. So the first thing let's look at this curve right here. This is what we call a normal curve or a normal distribution. And it's also sometimes called a bell curve because it looks like a bell. And so there's some characteristics of how this works. So remember that the Greek letter mu represents the mean. So in my graph, this center line is the mean or the average. And then each dashed line represents a distance of plus a standard deviation or minus a standard deviation. So in our normal distribution, and this is true for any normal distribution, once you go to the mean, and if you go to the right, a standard deviation, or to the left, a standard deviation, then in that much space, there is 68% of the data. Then if you go an additional 1 standard deviation, so you're out 2 standard deviations from the mean, that is going to give you 95% of the data. And then if you go out a 3rd standard deviation, that's going to actually give you 99.7% of the data. And in a normal distribution, it's always those numbers. So you need to remember those numbers, you need to learn those. So 68%, 95%, and 99.7%, depending on if you're within 1, 2, or 3 standard deviations. Okay, some other really important things about a normal distribution. In a normal distribution, the data is symmetric. And so you can see my picture, it is symmetric. And that's how normal distribution works. Now, you don't get normal distribution with just any set of data. But if you take enough surveys and get enough data, you're going to get a normal distribution because most people, so to speak, are average. And so that's how we get normal distribution. You look at enough data, and most of it is average, and then you get on both ends of that. So if we did test scores, if I get a class of 30, it's probably not going to show a normal distribution. But if I got a group of 3,000, it's going to be a lot closer to being a normal distribution. In normal distribution, you'll notice that we have half of the data is below and half the data is above. And so what happens is because it's symmetric, the data or the mean is also the same as the median. And that happens in symmetric data. Also, it's the mode. And so this, when we're looking at our normal curve, we have this point in the middle, which is the middle, and it's the mean, and then you go out a standard deviation in both. So some examples of where you see standard deviation. If you get the heights of enough people, it's going to fit in a normal distribution. If you get blood pressure of enough people, it's going to fit in normal distribution. If you check the items produced by a machine, they're really small deviations, but you're going to get normal distribution. Test scores. Big example of this would be something like the ACT test or the SAT test. Okay, college entrance tests that are given nationwide, Iowa tests. Even the state tests, they're what we call normed tests. And so what happens is these have been normed so that most people are going to be average. Then you're going to have some that are above average and some that are below average, and then you're going to have a few that are really above average and a few that are really below average. And so that's going to happen in any type of normed test situation. Now, the tests in my class, they're not normed. Number one, I don't have enough students to norm a test. If I decided I was going to norm a test, then what would happen is like right now in my class, most test scores look like this, meaning most students are on the higher end of the scores. If I was to norm the test, then what would happen is I would take whatever the middle was, and that would become my average. And the higher end, I would have very few of them and few of the low. So if I decided to norm it, then whatever the middle 68% of students got, that would be a C. And then I would take an additional, 20% or so, and that would be a B, and this would be a D, and then I'd have just a few people that would get an A, and the same amount of people would get an F. And that's what a normed test would look like. So I don't norm the tests in my class, and so I don't curve them or anything like that. So that's what that is called. Okay, let's look at some situations where we are going to look at standard deviation. So I've got 75 test scores from a couple of classes on a test. And I'm not going to have you put this in your calculator. That's a lot of data. But I did it for you. And so in this data, I found the mean was 18, the median is 19, and the mode is 19. The standard deviation is 4.5. So according to what we just saw, if I look at this as a normally distributed set of data, then I'm going to have this normal curve, and the mean in the middle, that's going to be 18. And then the standard deviation, if I go plus 1 standard deviation and minus 1 standard deviation, that's going to put me between 13.5 and 22.5. And that would be 68% of the test scores. Okay, let's just see if that's true. So if I look at the scores between 13.5, then I'm going to start right here. And then if I go up to 22.5, right there. So let's count how many scores are between these two. So count how many. Okay, so there's 52 scores that are between the 13.5 and the 22.5. So if I do 68% of 75 scores, what do I get with that? So doing the math, I get 51. And so that's really close, keeping in mind that this is only 75 scores. So if I had a similar showing from another 75, it would be a lot closer to 68%. So that's just kind of how this is going. And so because of the numbers, that's how I get the median and the mean and all of that. So that's where I'm getting that. Let's look at some other examples. Okay, number one, 95% of students at school weigh between 36 kilograms and 80 kilograms. Assuming this data is normally distributed, find the mean and the standard deviation. So let's stop and think about this. Whenever we talk about normally distributed data, we are talking about a situation that looks like this. So if I say 95% of students, how many standard deviations is that? So if you go back and look, 95% is 2 standard deviations. So let's draw a picture of that situation. So I'm going to have my mean, which is right here. So I'm going to put that. And then plus a standard deviation on either side. And then another standard deviation on either side. So that's plus 1 standard deviation. And then plus 2 standard deviations. And minus 1 and minus 2. So that's going to give me 95% of my data. So between there and there, I'm going to have 95%. Okay, so it says the mean is the one that's going to be in the very center. So if I look at my numbers, this is between 36 and 80. So what I'm going to do to find the mean, I'm going to do 36 plus 80, and then I'm going to divide by 2. So 116 divided by 2 is 58. So that means that my mean is 58. 58 is right in the center of those two. 95% of the data is in a normal curve is within 2 standard deviations. And so what I'm going to look at next is what's the difference between 58 to 80? How much space is in there? And so it's 22. Notice it's also 22 that way. So between 36 and 58, it's also 22. So I'm going to take that much space and I'm going to split it up between two standard deviations. So 22 divided by 2 is 11. That means that my standard deviation is 11. So let's turn this problem around. This means that if I have the student weights, and if I say that the mean is 58, and then my standard deviation is 11, then within one standard deviation, so between 47 kilograms and 69 kilograms, that's going to be 68% of students. If I go an additional standard deviation out there, I'm going to have between 36 and 80, and that's going to be 95%. And if you look, that's what we were told in the beginning. So this works, and I know I've got the right answers because my standard deviations work. The standard deviation is telling me how spread out it is. So if the standard deviation was like 6, then that means that these numbers would be smaller. So if I had like the weight was 58 and the standard deviation was 6, then I'm only going to have 64 and 52, so that's going to be 68. So there's going to be more students clumped up there in the middle. And then if I went another one, it would mean that 95% of students were between 46 and 70 instead of 36 and 80. So that's making a big difference. If my standard deviation was larger, so if my standard deviation was say 20, then I would have 68% of my students were between 38 and 78 kilograms. So that's a much bigger spread. The larger your standard deviation is, the more spread out your data is going to be. Let's try another one. Number 2, a mill cuts trees. So this is a machine cutting into framing studs. 99.7%. So how many standard deviations are we talking about? Go back and look. 99.7% is 3 standard deviations. So 99.7% of the widths are between 1.992 inches and 2.022 inches. Assuming this data is normally distributed, find the mean and the standard deviation. So since we're talking about normally distributed, first start by drawing a curve. Next, in the curve in the center is always going to be your mean. And then you're going to be looking at standard deviations on either side. So there's 1 standard deviation, 2 standard deviations, 3 standard deviations. So this is what I'm looking at here, and since this says 99.7%, I'm going to be using all 3 standard deviations. So it says that since the 99.7% are between 1.992 and 2.022, those are going to go on either end right here. Okay, I have to find the mean, so first thing is I'm going to find this middle point. So what's right in the middle of 1.992 and 2.022? So add them together and divide by 2. Okay, so I added them together, divided by 2, and I got 2.007. Okay, so the next thing that we're going to do is we're going to see how much space is between the mean and either extreme there. So I'm going to do 2.022 minus 2.007. And I'm going to get 0.015. So that's how much space is between here. So it's not a lot, but it's 3 standard deviations. If you checked, it's going to be the same amount that way. So if you did 2.007 minus 1.992, you'll find that that's also 0.015. Okay, so since that's 0.015, I'm going to see how much is in each of the 3 spaces. You're going to split it evenly. So 0.015 divided by 3, and that gives you 0.005. So that means that in this space between this point right here, if you add 0.005, you get 2.012. And then if you add 0.005, again, you're going to get 2.017. And if you add 0.005 again, you get 2.022. You have to make sure it works out like that. If it doesn't work out like that, then you did something wrong. I can go back the other way as well. I can say 2.007 minus 0.005. And I get 2.002. And then if I subtract 0.005 again, I get 1.997. And if I subtract 0.005 again, I get 1.992. So this is showing me where or how much everything is varying. So within one standard deviation, you're going to have 68% of these framing studs are going to be between 2.002 inches and 2.012 inches. So that's not very much. Okay, not very much of a difference. But the question is the mean. So that's the first thing I found, and that was 2.007. And the next thing was the standard deviation, and that was 0.005. So those are the two things that I was asked to find. Okay, the next example, if the mean weight of baby chicks is 22 grams and the standard deviation is 2.5 grams, then where do 68% of baby chicks lie between? So we're going to make our curve, because we're not talking about standard deviation and mean if we're not talking about normal distribution. So we're going to have the mean is 22 and the standard deviation is 2.5. So I'm going to add one standard deviation to either side. So I say 22 plus 2.5 and 22 minus 2.5. So that's where 68% lie, between 19.5 grams and 24.5 grams. 95% of the baby chicks are going to be within two standard deviations, so I'm going to go add another standard deviation. I'm going to add another 2.5, so that's going to get me to 27 on the right, and then subtract 2.5, so that's going to get me to 17 on the left. And so 95% of the baby chicks are between 17 grams and 27 grams. So standard deviation, just to summarize, is a measure of variability. It tells you how spread out things are. And standard deviation works directly with this normal distribution idea. You need to know the 68%, the 95%, and the 99.7%. Why it's those percents? Because that's how it works out. Weird, but that's how it does. So anyway, that's what you need to know about standard deviation. The rest of this lesson will be continued in the next video.